Hi fellas, this is Julius here again with another video. In case you missed my previous videos, you can watch them on YouTube. Just search the name Julius Baliklo on YouTube or on Facebook, and you can watch all my videos there. Today's lesson is going to be based on derivative of exponential. Derivative of exponential. Yeah, so that's what I'm going to be dealing with today. So how do you solve any question involving exponential when dealing with derivatives? So for instance, you have d over dx. Let me say this. So if you have y is equal to, you say, e to the power kx. So here, the e is an exponential. You have k here, which is a constant term. Then we have x, which is a variable. So this is an example or a question involving exponential. So how do we take the derivative, or how do we differentiate this? So we can say y prime of, let's say the variable x is x, so we are taking the derivative with respect to x, or we are differentiating with respect to x. So y prime of x is equal to, so the rule says simply bring down the power multiplied by the whole of this term. So we have k, which is the constant, and multiplied by e to the power kx. So that is the formula we're going to be dealing with. All right, so let's go straight to examples and apply this formula. So let's example 1. We have d dx of, all right, let me see. Let's say you have y is equal to 1000, then e to the power 0.07x. So how do we, take the derivative? How do we differentiate this using our example? Oh, sorry, our formula. This. So, so you can say our y prime of x is equals to, here it's, oh no, sorry, this should be 1000. Let's say 1000 here. Sorry, make it 1000. Then e to the power 0.07. So 1000 is a constant term, so you can bring 1000. Now we differentiate the exponential. This is an x. So here our constant term is 0.07, and then we have our x term here, and then we have our exponential, which is the e. So 1000, then we have to differentiate d dx of e to the power 0.07x. Right. So you have the y prime of x is equal to, let me rewrite it here, 1000 d dx into bracket e to the power 0.07x. All right, so let's now take the derivative. So y prime of x give us 1000. If we differentiate this or take the derivative of e to the power 0.07. So when you apply the rule or the formula, you simply bring out the constant here, which is 0.07. So this times 0.07, then multiply by the whole of that, whatever is in the bracket. So e to the power 0.07x. So y prime of x will give us, if you multiply this by that, it gives us 70, then e to the power 0.07x. So this is our final answer. All right, so let's look at another example, which is a little bit complicated. So example 2. So if a P of t is equals to 400, then all over 1 plus 3 e to the power minus 0.5 and t. So this is not a straightforward example or question whereby we can just apply our formula straight. So we have to look at, this is 400 divided by this. So if we go back to our quotient rule for anything, if you are dividing two functions, then you have to apply quotient rule. You cannot just solve it straight away. So we have to apply quotient rule to solve for this. So, and if you can remember our quotient rule, it says that you hold the guy at the bottom, 1 plus 3 e to the power minus 0.5 t constant, then we differentiate the guy at the top, which is 400, then minus, we hold our 400 as a constant, then we differentiate the guy at the bottom, which is 1 plus 3e to the power minus 0.5 t, then all over the guy at the bottom, then we square it. So that's what we're going to apply. So we are, trying to use what we have learned in the past to solve this. All right. So our p prime of t, that is, we're taking derivatives of this. So we hold the guy at the bottom constant. So we have, this is equals to 1. It's equals to what? 1 plus 3e to the power minus 0.5 t. We are holding it as constant. Then we differentiate d dt of the guy at the top, which is 400. Then minus, we're holding 400 as a constant, then we differentiate the guy at the bottom, which is 1 plus 3e to the power minus 0.5 t. So the 400 into bracket, it is d dt of 1 plus 3e to the power minus 0.5 t. Then this will be all over that will be 1 plus 3e to the power minus 0.5 t, then you square it. Right. So let me write it at the other side, then we'll solve it. have p prime of t is equal to, it's 1 plus 3e to the power minus 0.5t. Then we have to differentiate d dt of 400, the minus 400, as we have to hold 400 as a constant. Then we'll differentiate this guy, which is 1 plus 3e to the power minus 0.5t, then all over 1 plus 3e to the power minus 0.5t, all raised to the power 2. So here we have to differentiate this guy. So but it's a constant term. Any constant term, when you differentiate, it becomes 0. So when we differentiate this, we get 0. So 0 by this will give us 0. So here we have 0 minus 400, then to bracket. So let's differentiate this guy. So if we differentiate the constant term 1, it gives us 0. Now here you have 3e to the power minus 0.5t. So that's where we apply our exponential rule. So we'll bring the power, the constant term, which is negative 0.5, multiplied by the whole of that, whatever is in front. So have negative 0.5 and times 3e to the power minus 0.5t. Then this is all over 1 plus 3e to the power minus 0.5t, all raised to the power 2. So here you multiply negative 0.5 times 3, give us negative 1.5. So negative 1.5 times negative 400 will give us 600. What's 600? You have e to the power minus 0.5t. Then all over 1 plus 3 e to the power minus 0.5t. Then square that. Alright, so that becomes our final answer. So please comment, share, and like. Thank you for watching. See you in the next video. Bye.